Now we need to define what a neighborhood of a point is, or a neighborhood of a number, a real number. Okay, let's suppose that S is a subset of the real numbers, and let X be any real number. The set S is a neighborhood of X if there exists epsilon greater than 0, an epsilon, positive epsilon, such that this whole epsilon neighborhood of X, in other words, the interval going from X minus epsilon to X plus epsilon, is completely contained in S. So, if I'm the number X, I'm in the neighborhood S if, well, first of all, I have to be in the set S. And not only am I in the set S, but I can at least go out to the left and right at least a little ways, some small number epsilon, where that whole interval is also contained in S. All right, which of these is a neighborhood of X equals 1? Real numbers. Well, hopefully that's obviously yes. You could actually pick any epsilon. If you're the number 1, I'm in the interval from 0 to 2. I'm in the interval from 0.99 to 1.1 or 1.01. So yes. The rational numbers. Now that's an interesting one. The number 1 is a rational number. But is there an interval around 1, surrounding 1, that is completely contained in the rational numbers? And the answer to that is no. Do I expect you to know that right now? Absolutely not. But we will learn later that between every 2 numbers on the real line, there are numbers that are rationals, but there are also numbers that are not rational numbers. So every interval around 1, surrounded around 1, is going to contain elements that are outside of this set. So no. Is the number 1? Is this a neighborhood of 1? Absolutely it is. You could take the interval centered at 1, just go out a half, or go out 1. 0, 2 is an interval that contains the number 1, and it's completely contained in this interval. D, the interval from 1 to 2. Well, that's easy. The number 1 is not even contained in that set, so it couldn't possibly be a neighborhood of the number 1. Now this one might be a little bit tougher. The interval from 0 to 1, this time the closed interval, so 0 and 1 are in this set, this interval. Well, it turns out no, it is not. This set is not a neighborhood of the number 1. Why is that? You can only move in one direction. If I pull up a small epsilon where I go 1 minus epsilon to 1 plus epsilon, look at all these points on the right-hand side of 1. They're not in that interval. And it doesn't matter how small that interval is, you're going to get points outside of this set. So no, this set is not a neighborhood of the number 1. Oh, this is obvious. This is like 1 minus epsilon, 1 plus epsilon. Sure, that's a positive number. Absolutely, it's a neighborhood of 1. The set of integers. Of course not. The number 1 the set looks like this. Just pick anything less than 1. 1 plus or minus a half, for example. That's an interval that contains 1, but that interval is not contained in the set S. And it doesn't matter how small you make that interval, it's not going to be contained in the set, I'm sorry, I said S. It's not going to be completely contained in the set of integers. In fact, there's no interval contained in the set of integers. It's a collection of isolated numbers, isolated points.